In this video, we're going to cover section 11.6 on the preparation and reactions of acid and hydrides. Now, there are two methods that we'll look at for the preparation of acid and hydrides. The first involves starting with a carboxylic acid and converting it to the acid and hydride with excessive heating. So as you can see, we're using very high temperatures to carry out this particular process. As a result, we will form the anhydride and will produce a molecule of water. So we refer to this reaction as a condensation reaction. Now, another method to prepare an acid anhydride is to start with the acid chloride and to react it with a carboxylate ion. And that produces the anhydride and some salt. So as we saw previously, this reaction proceeds by nucleophilic acyl substitution, where now the nucleophile is the carboxylate ion. And so we have the carboxylate ion, the oxygen center, attacking the carbonyl carbon, breaking the pi bond to form our tetrahedral oxide. We then have reformation of the pi bond to give us back the carbonyl and loss of the leaving group, the chloride. And so we end up with the following acid anhydride as a result. Now, the reactions of anhydrides are directly analogous to the reactions of acid chlorides. The only difference is the identity of the leaving group. So for the acid chlorides, it's the chloride, and for the acid anhydrides, it's going to be some carboxylate. So it should be no surprise that the reactions in which the acid chlorides undergo, we're going to see the same set of reactions for the acid anhydrides. Now, one interesting example of acid anhydrides is the use of acetic anhydride. Acetic anhydride is used to acetylate the precursor to aspirin and Tylenol. So in this reaction, it's the alcohol functional group that's reacting with acetic anhydride to give you this acetylated version, which is our target molecule, aspirin. Similarly, if we take a para-aminophenol and react it with acetic anhydride, we acetylate the amino group to give us our target compound, which is commercially produced as Tylenol or paracetamol. And so like we saw in the previous video, here is a figure to represent and summarize the reactions of acid and hydrides. And it's basically the same as what we saw for acid chlorides, only difference being the methods of production for the formation of anhydrides. So we saw we could use excessive heating, high temperature to carry out a condensation reaction of one or a mixture of carboxylic acids to give us symmetrical or unsymmetrical acid anhydrides. Or we could convert a carboxylic acid to the carboxylate in the presence of a strong base, and then use that carboxylate ion to react with an acid chloride to generate the corresponding acid anhydride. And similar to what we saw previously for acid chlorides again, we can form esters, various amides, we can reduce to the alcohols, and we can use those selective reagents, the lithium tri-T-butoxy aluminum hydride or the Gilman reagent to form both aldehyde and ketones, respectively. So if you have any questions about the reactions of acid anhydrides, by all means, send me an email. Thank you.